electrical charge. So, if you think back to thermo, we started talking a little bit about our good friends, the atoms. And we talked about the fact that atoms have a nucleus, which is made up of positive bits called protons, and neutral bits called neutrons, and then around the edge are the electrons. Probably 2 in there. Okay. And if you remember, those electrons are negatively charged, okay, and they sometimes move around. So what happens when an atom gains or loses an electron is that it becomes charged overall. Okay, so if it picks up an extra electron, it's now got more negative bits than positive bits, and it's negatively charged. It's got a negative electric charge. If it loses an electron to something else that's running around stealing electrons, then it's got more positive bits than negative bits. So it's positively charged overall. So when an atom loses or gains an electron, it becomes charged. And the charge can be negative or positive. So depending on if it's lost an electron or gained an electron. Okay. Like we talked about last week, different materials, different types of atoms, gain or lose electrons with different amounts of ease. So some substances swap things around really easily and become charged really easily, and others retain their electrons and are really unreactive. Okay. So a couple of things we need to know about charge. So electric charge is measured in something called coulombs, which may be new for many of you. Okay. And 1 electron has a charge of negative 1.6 times 10 to the negative 19 coulombs. Okay, so it's negative because an electron is negatively charged, but it's not got a lot of Wham per electron. So you need quite a few electrons altogether before you can work up a coulomb of charge. Okay, so somebody's talking about, I have a coulomb of charge, they have an awful lot of electrons. The next thing that's important about charge is that things that are charged the same repel each other, and things that are charged differently attract each other. So negative things will move away from each other, but a negative and a positive will attract. Okay, if you've ever played with a magnet and sort of flipped the ends around and tried to make it touch other magnets, usually one end is negatively charged and one end is positively charged. So you can flip it with regards to another magnet and it'll attract or repel appropriately. So like charges repel, and opposite charges attract. Okay. And the size of that repulsion or attraction, how repelled or attracted they are, depends on how big the charge is. So if you're dealing with a really big charge, it's going to have a really strong effect on things around it. If you're dealing with just a really tiny charge, the effect's going to be smaller. Okay. If the charge is big enough, so if you have two things that are charged the same, so both negative or both positive, and it's big enough, then things will move across space in order to get away from each other. So when lightning bridges down onto Earth, it's attempting to move away from things that are charged the same, or you can make magnets actually move in the air. Yes? Sorry, yes, it is meant to say. So like charges repel, correctamundo, and opposite charges attract. Good spotting, a key word there. And charges have an electric field around them. Okay. So these negative charges have an electric field around them, and these positive charges have an electric field around them. So you can think of it, if you're trying to visualize it or imagine it, kind of the same way as the Earth or your head or your drink bottle. Any mass has a gravitational field around it. So that thing will always attract other things due to its gravity. Obviously, the gravity of the Earth is more significant than the gravity of your head because its field is much bigger than the gravitational field of your head, unless you have a very, very dense head. And so electric fields work in the same way. So things with big charges have big fields. Small charges have small fields. And it's those fields that repel or attract things when they come and interact with each other. So just like with gravity, we can calculate the strength of the field. We can do the same thing with an electric charge. So we can say that the strength of the field, the electric field, exerts Okay, so like with gravity, the strength of it is to do with the force over the area, or like with any other force. Here we're talking about how much force you're putting out per coulomb. So the strength is your field, is your force divided by, we're going to call charge Q. Actually, in a fit of excitement, I forgot to put that in there. Okay, so coulombs, the unit that we use in our equations is Q. Okay, so the size of your force is of your electric field, and your strength of that is about how much force it puts out per charge. So a really strong field will put out a lot of force per charge. Yep, so for charge. Yep, is the Q. So it's measured in coulombs and the unit symbol is Q. So we can put a Q up there if you like. So gravity, if you think about it, is always an attractive field. Whatever enters gravity is going to be attracted in because of that field. The electrical field, it depends on how the things are charged. So if you have a negative electric field, that could attract other things or it could repel them. Depends if they're negative or positively charged. So it sort of goes two ways.